Okay. Yes. Good evening, everybody. So we are going to continue with organic chemistry. We have done the basics like what are organic compounds. We have also generalized about the saturated, unsaturated hydrocarbons. We have covered what is alkene, alkene, and alkyne with the general formula. So we have completed all those parts, and we have also understood the naming process like I've given you the hint. You are supposed to remember meth, eth, prop, and but, and this counting is for the number of carbon. Now I'm just proceeding to one more step which we're going to study today. One is briefly alkyl and one is functional group. Are they different? Do they have different functions? Yes. What are they? Let's do that first. So alkyl means what? They are the groups which decides the physical property of the compound, like the boiling point, melting point, the densities and all. Those are decided by the alkyl groups. Functional groups, they decide the chemical property of the compounds. Okay, they are the one which will let us know how it will react, with whom it will react, what will be the preferences for reaction. That is completely decided by the functional group. Okay, so you usually have few lists from the functional groups like alcohol, we have ketone, we have carboxylic acid, we have aldehyde. Okay, we have all these, but in your syllabus alcohol and carboxylic is completely omitted. It is not there. Okay, so the rest of them is there, but to a few limit. So we are going to do a little detail about this, but let us first come to alkyl. So out of this, as I said, alcohol and carboxylic, we are not doing that. All right, so alkyl means what? They are the physical property decider for a compound. And what are they? So you have the very first member of the hydrocarbon is CH4, which is methane. We all know this is methane. And when I say ane, we have learned this. Ane means they belong to alkane group. They are saturated compounds, hydrocarbons. Okay, and they all have single bonds. This is something we have constantly studying. Okay, now what I do, I remove one hydrogen from this, only one hydrogen. Then what will happen? This will not be called as CH4, this will be called as CH3. So should you call this as methane? No. This, when one hydrogen is removed, it will be called as methyl. Okay, similarly I can take for ethane. Ethane is C2H6, and what I do, I remove one hydrogen, so this becomes C2H5. So this is ethane, but after removing one hydrogen, this will be called as ethyl. Like that you can do for propane, that will become propyl. If it is butane, it will become butyl, and so on. So these are the alkyl groups deciding for the physical properties. Okay, now today we are supposed to briefly study about isomers. In your syllabus, positional isomers are not there, so we'll be doing a lot of structural isomers. Okay, structural isomers. So but let's first understand what are isomers, what are they meant. So isomers, they have same molecular formula, okay, but different structural formula. Okay, they have same molecular formula but different structural formula. Now what does that mean? We'll just take an example, you'll get a detail about it, and before doing that example, let us understand how to draw the various structure. So we have one structure which is called as straight chain. Okay, straight chain. Then the next one is called as branched chain, and the third one is called as the ring structure. So what are they? We will understand with an example. So I'm just taking an example of pentane. Okay, I'm going to just we are just going to do about pentane structure. So let's come to that point. So pentane, we know pent means 5, correct? And I'm taking ane means it is alkene group. Pentane means C5H12. Okay, how will be the structure? We have learned that also. First we are going to put 5 carbon and put all single bond between them. After that you are supposed to balance with hydrogen. How you will balance? You're going to check the carbon, check to all the corner. There are 4 lines, 4 bonds. Why 4? Because carbon has valency 4. This valency decides an atom is going to have how many bonds, or how many bonds it will make to become stable. So this carbon is already having 1 bond with the left carbon. So how much bonds left? 3 of them left. And who will balance them? Hydrogen. This carbon, if you check, has 1 to the left, 1 to the right. So 2 left, which will be balanced by 2 hydrogen. Like that, all the center ones I can see will be balanced by 2 hydrogen. And what about the corner one? Corner one is going to be balanced by 3 hydrogen. So this is the structure for pentane. And what I notice here is this is going to have 5 carbon, and if you count there will be total 12 hydrogen. So this is 5 on the top, 5 at the bottom, which is 10, 11 and 12. So there are total 12 of hydrogen, and this is the structure. This is the formula, this is the structure. All right, now understanding this kind of structure, you observe is all the carbons are in a straight line. Yes, all of them are in a straight line, nothing crooked, nothing going here and there. They're all in a straight line. Such type of chain is called as, such type of structure is called as straight chain. Okay, and straight chain is normally taken as or read or written as N pentane. What is this N? Why you call this as pentane? Why not just calling this simple pentane? Why N pentane? N stands for normal. Okay, N stands for normal, and pentane because there are 5 of them. So whenever there is a straight chain, you can directly give a name to it and you will say that as N-pentane. Okay. Now coming to the second type. So I hope the first type under this is clear. What is meant by straight chain? Whenever you have a structure like that, if I can do it for propane also. So propane has 3 carbon. I'll put 3 lines like this. First I will balance all the bonds between carbon, and whatever is left out as per valency, the remaining will be balanced by hydrogen. So we know for propane it is C3H8. Okay, and I can see all the carbon in a straight line. So this will be called as straight chain structure. This structure I've done is for propane. Okay, so the first one is very simple. When you are given a compound, all of them are in a straight line, they will be called as straight chain structure. Now we're going to do the second type. The second type is going to have certain rules, but very interesting. What we will observe here is branched chain. What does that mean? Branched chain means from the main chain, some carbon is not going to lie in the main chain. They will come out and branch themselves. Okay, but let us also first know the rules. So it is having all 5. There is no possibility of branching with 5 in the main line. So I'll have to reduce by 1. I'm going to take 4 carbon in this main chain. I have to use the same formula. Okay, this is C5H12. I cannot change that. This is 4, but I'm not going to write for C4. That is butane. I'm not going to do that. What I'm going to do here is I will take 4, but I have to also add the 5th carbon. Now where I will add, I cannot use these 2 corners. That's not allowed. Let's see why. So suppose I have 1, 2, 3, 4 taken and I have linked them, and I branch at this corner or let's say 1, 2, 3, 4, and I have branched at this corner. This kind of branching which forms L shape like this, or to the bottom also and also to the top, these structures is not considered as branching. They will be still called as straight chains. So the rule states you cannot do branching at the corners. You will have to use the middle one, intermediate carbon. You cannot do branching at the corners. So the choice is either I branch here or I can branch here. There are two choices. But I am going to tell you this thing, when the the chances of equality is same. So from this becomes a second position, and if you count from here, this becomes a second position. Then it does not matter whether you're going to put it here or you're going to put the branching at this end. It will mean the same. It is going to be the same. Why? Let's see that also. So I'm going to take the 4. I've taken an extra over here. Sorry. So this is not there. There are 4 in the main line, and then I'm going to take 4 carbon over here, and I'm going to branch at this position. Okay. So that is my 5th carbon will come here. 1, 2, 3, 4, and my 5th carbon is going to come here. The counting should not become different. This is C5 again. How you're going to balance the hydrogen? Let's check whether hydrogen changes or not. So this carbon is attached by 1 carbon already, so 3 is left. For this carbon, left and right is there, so 2 is left. There has to be 4 in total. For this carbon, if you check, it is 3, 1, 2 and bottom. So how much is left? 1 left. And for the corner, it is already 1 more 3. So you just have to count that total has to be 4 and do the remaining balance. And all will be balanced by hydrogen. And what about this? Even though you have branched out, it also needs to become stable. It will have its own branching. So that is 1, 2 and 3. Okay. So if you count, let's count how many hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So does that change the number? No. It is still C5H12. And what does this mean? If you look here clearly, this mentions that this structure is different. This is all straight. And if you check over here, they are not straight. The structure looks absolutely different. But what is common? You will see that the molecular formula is going to be common for both. Correct? It is C5H12 and C5H12. But they both look different by their structure. These are called as structural isomers. Means molecular formula is same, but their structures are going to be different. Now, let's see we can branch more or not. First, isomer we have made is all having 5. So we couldn't branch. So for branching, what I did, I've taken 1 number less. This is 4 and I've branched the 5th one. Okay, coming to this. Do you recall what is this? CH3. This is actually, if you write it in condensed form, this is CH3. I just gave you this idea at the beginning. This is alkyl group. CH4 is methane, but if you remove 1 hydrogen from it, this will become CH3, which will be called as methyl, which decides the physical property of the compound. But you may also ask me, these corners are also CH3, correct? These two and CH3. But these carbon are in the main straight chain. These carbon belong to the main line, the main chain. Okay, this carbon which is at the bottom, it is not in the main chain. It has been branched out. It does not belong to the main tree over here. It has been taken out. So this will be the alkyl group and not the corner ones. Okay, so this one, this is alkyl, or you can also call, this is actually called as substitute. They are very important part. They are going to decide the physical property. Okay, now let's see, can we do more branching? So this time I've taken 4. Let's reduce again this by 1 and let's take 3 in the main line. 1, 2 and 3. Okay, and I'm going to see where I can possibly do the branching. So with 3 in the main line, I cannot change the number of carbon. It has to be 5. So there is 3. 1, 2, 3. So more 2 is left. And as I said, at the corners, you can never do the branching. So where is branching possible? At the center. So two of them is there. So I can do that. I can fix two carbon to this centermost carbon. This carbon can attach to two more carbons, correct? And this property is called as catenation, right? This property at the very beginning we have taken is called as catenation. Carbon can get attached to carbon and like that more number of carbons. This property of carbon is helping it to make very long chains which are also stable. Just not like making a huge chain, but these chain of carbons are very stable by nature. So we have fixed these two and let's balance it. This is going to be balanced by 3 hydrogen, and this on the top will also be balanced by 3 hydrogen, 1, 2 and 3. And of course the remaining over here you have to balance the left one also. This is at the bottom. So which one is the alkyl over here? You are going to call these two 1 and 2 because they are part of the branch. These two corners that you see, they are part of the main chain. So your main chain is this one. A continuous longest chain. This is 1, 2 and 3. 3 carbon. If I count like this, it is 1, 2, 3. But what about these two? They are not in the branching part. So the branched one are these two and these are what? Methyl. We have already discussed. These corner ones will not be called as methyl. Remember that. Okay. So this is one more structure. This is different. This is different and this is straight. Okay. So they're all different by structure, but as I said, the formula is still same. If you count 1, 2, 3, 4, 5. 5 carbon. Let's count hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So hydrogen is again 12. Your formula is not changing, only the structures are changing. Now let's see, can we do for one more less? They were taken 3, take one less, which will be 2. Can we do that? No. Why? Because more 3 needs to be attached, but we know the branching cannot be done at the corner. They both are the only carbon present and they both are at the corner, so we cannot be branching it. We can't do that. We can't be branching with 2. So this is the utmost possible isomers we got. One is straight, one has been taken branched, and this one with this 3 in the main line and branched at the center. Okay. Now there can also be a question that with this, can we do a figure like instead of taking branching here, can we branch at this carbon? So even if you try to do a branching with that, that's not a different isomer. It is going to represent the same isomer. So let's come to this 1, 2, 3 and 4. Okay. Instead of this point, I'm choosing this for branching. So this is going to be balanced by 3 hydrogen and this will be branched with 1 and this with 2. Okay. So the rule states wherever you have done the branching, this is the position of branching. This is going to be closest towards this end, or is it going to be close to the left end? Okay. So counting will always start from either end, 1, 2, 3, 4, or count 1, 2, 3, 4. But wherever you have done the branching, which is closest? Is this carbon closest or this carbon closest? So of course this one is closest. So the counting will start from here. 1, 2, 3 and 4. So it's not going to be different. The same thing I'm going to do here. Branching has been done at this position. So this carbon is close or that one. So of course this is close. So the counting is 1, 2, 3 and 4. They both are going to be identical copies, like they are of the same position and numbering. So they both will be the same isomer. So in exam, do not draw and say this is one isomer and this one is another. No, they both are the same representation. So either draw this one or this one, but don't draw them together and count that as different isomer. So how many possible isomers did we get? 1, 2, 3. This is according to straight and branched isomers we have taken. Sometime in exam they do specify that only take the branched isomers. So in that case, you're not going to be considering this as the isomer. This is straight isomer. This is not branch. So don't take that. Sometimes in exams they do specify isomers. So if it is only branched given, do not take straight chain. Okay. And if they've mentioned ring one, so let's understand the last type, which is called as the ring structure. So as it is C5H12, a ring structure is usually a closed figure, okay, like a triangle or square or rectangle. Then you can have a pentagon for 5, then a hexagon, and like that. These are geometrical closed figures. So I clearly understand this, that we know pent means something referring to 5, and 5 is like a pentagon structure. So pentagon structure is a house kind of structure. All the vertexes over here is representing the carbon, and each carbon, let us see, try to understand this, how it is bonded. 1 bond, 2 bond. This is the second bond. This carbon is attached to 2 other carbon, 2 bonds gone. How much bond left? More 2, and it will be balanced by 2 hydrogen. Similarly for this carbon, 1 on this side, 1 on the top, 2 bonds already gone, more 2 left, and that will be balanced by hydrogen. Like that, it will be similar for all of them. Okay. Yes, it will be similar for all of them. Let's see how many hydrogen are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Isn't this different? Do you think it will be isomer then? No. Why? Because what did we state? When you're drawing the isomer, they have to have the same molecular formula. But if you check with this is not having C5H12, because we were doing for that, correct? C5H12. Instead, it is giving C5H10. Why this happened? Because it is not open. All these kinds were open at ends. They were not closed figures. So when this is again connected to this, in this case, let me say I've started from this as the first carbon. This is second, third, fourth, fifth. Okay, 5 carbon. Then the fifth is again getting attached to the first carbon, and because that is consuming the bond, in one bond it is being taken up between the 2 carbons connected. The first one is connected, again coming back to the same. So the last one and the first one are connected. This is the last one, this is the first one. They are not open chain, they are closed chain. They are connected to each other. So they are consuming one bond over here itself. They are not free, and that is why, if they were not connected, imagine they were not connected, then I would have balanced this corner by 3 of hydrogen and the first one by 3 hydrogen. So instead it is just having 2 and 2, means 1 is less over here and 1 is less over here. They both took away those hydrogen. Instead of bonding with that 1 hydrogen, they themselves bonded with each other. That's why 2 hydrogen is less from the regular molecular formula, which is for C5H12. And instead we are getting this as C5H10. Okay. So remember, ring structure you can draw, but the molecular formula will be different. It will not be the same. Okay. So this we have done today is about the isomers. Okay. So what all we did, let's just give, let me just give you a little brush up about, a little summary about whatever we have done so far. Okay. So we have understood that there are 2 basic groups that we need to study. Primarily, we have already done with the saturated, unsaturated, alkane, alkene, alkyne, and the general formula. So this is what additionally get attached to a very normal hydrocarbon. So alkyl can get attached, that is because of branching, or some functional group can get attached. So functional groups are all of these list. They decide the chemical property, whereas alkyl group, they are always one hydrogen less from the main type. If it is methane, it will become methyl. This will, instead of CH4, it will become CH3, like that ethyl, like that propyl, butyl, and so on. So this is always taken from the saturated hydrocarbon. And then what we see, what we notice, there are some isomer concepts that we need to do. Isomers, specifically targeting the structural one. What are they? They have the same molecular formula but different structural formula. So we have studied three types. One is straight chain, branched chain, and ring structure. Straight chain means they are supposed to be like, suppose I give you propane, this is C3H8. All the three, there are three carbon here, all the three are one after the other, successively arranged in a straight line, and they are called as straight chain, which is also given another name, which is N, like N propane, N pentane, and N stands for normal, and this is only when you are representing straight chain. Okay, so this example we have taken for pentane, this is C5H12, all the 5 carbon arranged in straight manner, and remaining is all balanced by hydrogen. Then we do a branching. And how do we keep doing branching? From the main chain, keep on reducing one carbon. So it was 5, now it will become 4. Try to manage the 5th one, and just know one rule, that you cannot do the branching at the corners. That is what you will have to be making yourself sure about while doing the isomers. And if there are similar type of isomer, I told you for this one, this is going to be same. Okay, they are not different isomer, they will be the same. And then from 4, then you can try 3. Also check, can you go further? If not, that is the utmost number of isomers that you can draw. And from that itself, we try to take the ring structure, which is closed figure. But we will always notice, whenever you have ring structure, at least 2 hydrogen will become less. So for this, we will take one more example. Let us take for butane. Okay, let us take for butane and understand the same thing. So we know butane is what? Butane is 4 C4H10. This is butane. So how many hydrogen, how many carbon in the main line? There will be 4 of them. 1, 2, 3, 4. What I will do, I will balance the rest by hydrogen. So 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. So let me balance all by hydrogen. Okay, so this is my C4H10. So this is straight chain. This can be called as N-butane. Okay, now we'll start branching it. So it was having 4, take 1 less. So I'll take 3, 1, 2, 3. And I'll fix that 4th one somewhere. But of course, I know I cannot fix at the corner. I'll have to take the center one. So this is the same. Okay, I'm also giving you another way of representing it. 1, 2, 3. Instead of taking it to the bottom, I can also take it on the top. It is not going to be different. This on the bottom or take it on the top, it will be the same. So I'm just writing condensed form. I'm not doing all the dashed one. These are called the wedge dashed one. These are the condensed. So I'm not taking all the dashed one for the corners. Okay. And you'll have to balance this with one of the hydrogen. Okay. Always check carbon is surrounded by total 4 lines. After this, let us do one more branching. Is that possible? So from 3 reduced to 2, that's not possible. I cannot do a branching in this manner because 2 is there and they are the corners. So I cannot do branching at the corner. So these are the possible isomers. Let's take the ring structure of it. Butane means 4. I can have a closed figure with 4 vertex, means it will be like a square or a rectangle. So this is butane. The corner always represents the carbon. These are all the carbons. And check the bonds. 1 carbon is attached, 1 to the left, 1 to the bottom, 2 left. So 2 balanced by 2 hydrogen. Like that, it is going to be same for all of them. And you will observe 2 hydrogen will be less. So this is 4 carbon. I can see I'll write C4. But how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. So it is how much less? Always 2 less. So that's how ring structure and never the isomers. Do try to represent butane with 4 carbon, but hydrogen will not get balanced. Okay. So this is how we have done today about isomers, and clearly we have taken a lot of alkyl group in this situation. Okay. Now let us, I'm giving you one question where we can find, I'm just giving you some oral questions. There is total number of different carbon chains that has 4 carbon atoms form in alkene. So you just have to tell what is the total number of different carbon, how many carbon chain, like that. This is one chain, this is one chain, like this. How many chains can you make when you have 4 carbon atom? Now that is something very valid right here, because this example we have just taken here. So the first understanding is they are asking how many chains can you get. So, and when the number of carbon is 4, so when the number of carbon is 4, that is definitely for butane that they are talking about. Correct? They are talking for butane. And how many chains did we get here? Only 2. 1 and 2. These 2. So the correct answer will be 2 chains we can get. And when they say chains, that is actually they're talking about isomers in this condition. Okay. Then you have to tell a general formula which goes, I've already given you. Alkene is CnH2n. Like that you're going to learn. Top one is alkene, CnH2n plus 2. Okay, this is always going to have 2 hydrogen more. And to the bottom it is alkyne, which will have 2 hydrogen less. So this is going to be what? This is going to be lesser in number. So just the trick is, if number of bonds are more, then the number of hydrogens becomes less. This is how you can remember. Suppose I have carbon to carbon to the single bond. How many hydrogen I will have? I will have 1, 2, 3, 4, 5, 6. Okay. So that will be C2H6. This is saturated. This is alkene. Okay. With the same number I'm taking, I am wanting to have a double bond. So carbon is already stable. But if it wants to have a double bond, so this double bond, triple bond, you're going to only check between carbons. Double bond, triple bond is never between carbon and hydrogen. That's not even possible, because hydrogen can only make single bond. It cannot even make a double bond. Okay. So if carbon and this carbon decides that, okay, let's have double bond. Okay. So what they do, they will have to leave one hydrogen. One from this end, and this carbon will also have to sacrifice. So this hydrogen will be removed. So that bond that was available will get free. They will try to contribute into this bond, and that is how they make double bond. Okay, but that is not a direct method. There is some procedure through which this happens. So we can say this is now left out with, because if you check carbon 1, 2, 3, 4, for this carbon also 1, 2, 3, 4. So C2H, but now the total is 4. If you check, the number has reduced by 2. This is what? This is alkene. And according to the naming, it is ethene. This is ethane. Now one more bond if they want to make, then again they're going to sacrifice one hydrogen and then move their bond into making triple bond. Okay. And then how much hydrogen will be left? Only 1. So now it is C2H2. More it becomes less. From 4 it will become less by 2. Every time observe that it is going to become less by 2. Alkane has more hydrogen than this thing, alkene. And the least one will be for alkyne. This is the alkyne category, which is called as ethyne. Okay, so remember, as the bond increases, the number of hydrogen will keep on reducing. Okay, that is how you're going to remember. So there is a question. How do you compare propane and ethane? What is the common thing? That absolutely two different compounds. Yes, this has 2 carbon, propane has 3 carbon. But what is common? If you check their ane, okay, ane means they are homologous. They are going to be homologues of each other. So the correct answer, there is just like some MCQs. They are homologues for each other. They belong to same category of alkanes. Okay, so there is also a question in homologous series, what is the successive member? We will always add CH2. This is as per formula, or let's say 14 AMU. Remember this point. So if I say what is the difference between ethane and propane, why did I call them as homologue? Is because if I check C3H8 and I check C2H8, how much is the difference? Carbon is 3 and this is 2. So there is a difference of 1 carbon. And this is 8, this is 6. How much difference of hydrogen? 2. So C1, I'm not writing that 1. It can be written as CH2. This CH2, correct? So they are going to be differing one after the other. So it is methane, ethane, then propane, then butane, then pentane. Like that, if they are in an order, one below the other, successive, then the difference between them is for CH2. And why did I write 14 AMU? 14 means carbon has atomic unit as 12. And hydrogen is 1, but there are 2 of them, correct? One is the AMU, but there are 2. So that will be 2 into 1 is 2. 12 plus 2 is 14. So they can also, you can write it as per the formula, that is CH3 unit, or you can write how much by molecular mass they or atomic mass they're going to differ. So that will be 14 atomic mass unit. Okay. So that is some questions that we have quickly taken. Then okay, so yes, we'll take one last question. So it is C25H52 and one is C50H102. So do they belong to same homologues series or do they belong to different homologue series? Okay, so there is a quick review I can give you. Take this number, take the double of it. Okay, if you're not really memorizing the general formula every time, you're getting confused. If this is not memorized, this is something you will have to do because they can ask you in writing. But just for solving purpose, this is number 25. Take the double of it. Double of 25 is 50. And add 2 to it. If this is becoming 52, this belongs to alkene group. Okay, if the number is 25, okay, and the number is exactly the double of it, this number is 25, hydrogen number is exactly double of it, 25 2s is 50, then this is belonging to alkene group. Okay, the number is again 25, but this time the number of hydrogen is going to be 48. How? 25, double of that is 50. And in that, if 2 is subtracted, then this will be belonging to the alkyne group. This is how you can remember. Just note to take the double. So this is definitely, this I've just checked that double of it and add 2 to it, because the general formula say Cn and this is twice n, double of it, and add 2 to that number, then it belongs to the alkene group. Let's check for this if it is working the same way. 50, double of 50 is 100, and this is 102 means plus 2. So this is also alkene. If they both are alkene, they are definitely homologues. They are not different series. They are homologue series. Okay. So that's it then for today. Rest some reaction methods. We'll be taking it tomorrow. All right. Okay.